Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to explain the Kaplan turbine working with animation. Kaplan turbine is the one of the hydro turbine or a water turbine, and its definition and also the working with animation I am going to take in this session. Here, the Kaplan turbine is the low head, high flow rate axial flow reaction turbine. It requires a low head. Even though about the 2 meters of the head also this turbine works. The head range is between the 2 to 25 meter. That's the vertical height from the turbine level what it is required. And it requires higher flow rate. The higher flow rate is about the 80 to 700 meter cube per second of the flow rate is required. The quantity of the water flow required is higher for this Kaplan turbine. It's the axial turbine. Means while flowing along the axis of the shaft, the energy conversion is taking place. That means the fluid power to the mechanical power conversion is taking place when the flowing along the axis of the shaft of the turbine. And it is a reaction turbine. Reaction turbine means here the pressure of the flowing fluid in the turbine will be continuously changing. And the energy available at the inlet of the turbine is both the pressure energy and the kinetic energy. And this is the definition of the Kaplan turbine. How it works, we'll see that. Here the water is stored in the dam where it will have the potential energy. When it is flowing through the penstock, the line connection between the dam and the turbine, the potential energy is converted into pressure and kinetic energy. Then here the Kaplan turbine is having the volute casing, that is a decreasing cross sectional area casing, and there the whatever the velocity is there, the kinetic energy present in the water is imparted to the impeller of the turbine, the rotor of the turbine. And while flowing through the guide vanes as well as this main rotor, the kinetic pressure energy present in the water will be converted into kinetic energy while flowing between the blades of the guide vanes. And that again the kinetic energy is imparted to this impeller, that is a rotor of the turbine, thereby the rotary mechanical energy we are going to get. And this shaft is connected to a generator. It is an electrical generator which generates electricity, and that electricity is supplied to the powerhouse where its voltage will be increased in order to transfer them through the lines to the grids, and that is transformer will be used, and transmission lines is used to transfer the electricity to the grids. And as it is a reaction turbine, in this one all the pressure energy is converted into a kinetic energy, then kinetic energy is imparted to the impeller of the turbine, thereby the outlet pressure will be reduces below the atmospheric pressure, and that's why the outlet pressure will be lower pressure. That's why the discharge from the turbine should be discharged through the draft tube. Draft tube is the conically increasing cross-sectional area component which will somewhat increases the pressure of the flowing fluid. Otherwise, there will be back pressure acting on the turbine, and that will reduces the turbine efficiency. And through the draft tube, that will be discharged below the tail race. The water is discharged below the tail race. And how the turbine working and how the blades are arranged in the next slide we'll see that one. Here we can see the water is entering through the guide vanes, and there the pressure energy is converted into kinetic energy, and the blades of the turbine are attached on the hub, which will be the fluid will be flowing in the downward direction. And along the axis of the shaft, when the water is flowing. During that time, the energy conversion of the fluid energy into the mechanical energy taking place, and that's why it is called as a axial flow turbine. And here the draft tube increasing cross-sectional area, that part that is called as a draft tube is connected at the exit of the turbine. Like this, even though if we have the low head and higher flow rate of the water, if we have, then the Kaplan turbine can be used in order to generate the electricity from the water. And this is the another type of the hydraulic turbine. And already I have explained the other two types of the hydraulic turbines, and comparison I'm going to take in the further session. Thanks for watching Engineering Explained channel. If you like, kindly subscribe, share and comment.